Chapter 8, Division in Scientific Notation. In this video, we will complete the two examples in your foldable, so open the flap that says Divide Numbers in Scientific Notation. After we finish, you will try the two division examples on the left side of your ISN. We will be working on these two examples right here, so I'm going to zoom in, and we'll be following the steps right here. Before I do that, it's important to note that for both multiplication and division, the powers of 10 do not have to be the same. With multiplication, we know that we added the exponents on the 10 because we had the same base, so we add the exponents. And for division, we'll do something different. Before we do the examples in the foldable, I want to remind you of a few important things. First of all, if we have this, 3x to the fifth over 6x squared, we think of this as two separate parts. The 3 over 6 part, we simplify, so we have 3 over 6. We can divide the top and the bottom by 3, and that's how we simplify this to 1/2. Because really, this was like dividing or multiplying by a giant 1, which doesn't change our value. Then we also have this part on the right, x to the fifth over x squared. And we learned our rule that we subtract our exponents and we write the result wherever the bigger exponent was. So this will be x to the third. This is because we are dividing the top by x and by x again, and we are dividing the bottom by x and x again. So we are left with 3 x's on the top that are being multiplied in the numerator, and no x's on the bottom, so our denominator is just 1. Now let's look at our division examples, and we'll keep those facts in mind. Our steps say we need to divide the decimals, divide the powers of 10, which means we keep the same base and subtract the exponents, and finally adjust the decimal point and power of 10 if necessary to write our answer in scientific notation. So let's do it. We have 4.2 divided by 2.1. You may notice that this goes in exactly twice. If not, we can always do our division over to the side. 4.2 divided by 2.1. We cannot divide by a number that's not an integer. So if we move our decimal point over one place here, we have to move it over here as well. So our new problem is 42 divided by 21, which is 2. Now we have 10 to the fourth over 10 squared, and we simplify that to 10 squared because we subtract our exponents. In other words, we divided by 2 powers of 10 up top and by 2 powers of 10 the denominator. So we have 2 times 10 to the second power, which is given in scientific notation because we can either have one digit and then a decimal point times 10 to some power, or just that one digit, so this counts. Let's look at example 2. We have 6 over 12, and we have 10 to the fifth over 10 squared. I can split that up if I want to. You don't have to. 6 over 12 is 1/2, but in scientific notation, we keep it as a decimal, so we have 0.5. 10 to the fifth over 10 squared is 10 to the third, because again, I subtract my exponents because I divide the numerator and denominator by 2 powers of 10. This is not given in scientific notation yet, so I'm going to move my decimal point over one space to the right by multiplying by 10, which means that I have to subtract 1 from my exponent because I made the left number bigger, and so I need to make my 10 to the power smaller. That way I don't change the overall value of the number. So I have 5 times 10 squared as my final answer. Now it's your turn. Try the two division problems, number 5 and 6, on the left side of your ISN. These may look a little bit different, but the reason why they look different is that they're written with the division symbol in the middle. That's only because it's easier to type and for space reasons. So you can start by rewriting your problem as 8 times 10 to the 8th, all divided by 2 times 10 squared. Best of luck, and see you tomorrow in class where we will check our answers.